Before, okay. See, before going to the measure phase, why we need to measure? Can't we move? Can't we execute a project? Can't we solve a problem without measuring it? So there is a general. See, can't we solve the problem without measuring? So there is a general statement given by some of the management people. They say, what's not measured cannot be monitored. So if you want to monitor and control things, definitely we need to measure. So what's not measured cannot be monitored, and what's not monitored cannot be controlled. What's not controlled cannot be directed. So measurement is critical and important. That is why we have the measure phase as the second one. After defining the problem, we need to measure the range of the problem. We need to measure that the problem actually exists. Okay, we have to verify that. We have to prove that. So we need data. So when it comes to measure phase, you will see what are the objectives and the steps involved. There are 3 steps involved, and the tools and techniques which we are going to use in the measure phase. All Lean Six Sigma um, phases have important tools and techniques. We will see how these tools and techniques can be used for a measure phase, so that how these tools and techniques can be used so that the measurement which we are doing will be correct one. Okay. Okay. Sorry for that. So let us see what are the objectives of the measure phase. See, we have defined the problem. We want to verify the problem statement. See, I just want to recall you the previous objectives. That is, we want to identify the project. We want to select the project. We want to develop the project charter and the SIPOT. Now, so we have identified the project. We have selected the project. Now we have to verify whether we have to do the problem statement, whether we have to do the project. How we can verify that? Just by checking the data, just by measuring the data which show that actually the problem exists. So we have to verify the problem statement given. See, my flow supervisor is saying that the cycle time is more. Okay, I accepted the problem. I have to verify it before going to the next step to find a solution for it. Okay, I have to check whether really the cycle time problem exists, or it is the poor judgment of my supervisor. I have to verify that. That is very critical, because in Lean Six Sigma process, he doesn't move to the next step without confirming. That is why Lean Six Sigma projects are valid, and why Lean Six Sigma projects are mostly successful. The reason is they confirm it at the end of each and every phase before moving to the next phase. Then we need to use a measurement system. For example, I may be using vernier caliper, I may be using a screw gauge, or even I may be using a stopwatch. I need to validate the measurement system which is being used to measure the data. A measurement system will be used, right? If I want to measure the cycle time, if I want to do the motion study, we will be having a measurement system. So for example, in yellow belt also, we have a measurement system. In green belt also, we have a measurement system. We will give you assignments. We will conduct your activities. At the end of the program, exam will be conducted. So there must be a measurement system. We have to check whether the measurement system is a valid one. See, for example, I have to measure 0.01 mm, but I am using an ordinary scale, steel ruler. Is it possible to measure 0.01 mm accurately with the ordinary steel scale? No. For that, I need at least a screw gauge or some digital measuring instruments. So I have to make sure that the measurement system which is being followed is the valid one, is a correct one, is a proper one. Okay, then measuring the baseline performance. Okay, so these are the 3 critical important and objectives of the measure phase. You have to verify the problem statement. You have to validate the measurement system which we are following. Okay, and we have to measure the baseline performance. I will say what is the baseline performance. So what are the steps involved? See, if you want to, before going to the validation of the measurement system, we have to finalize the CTQ performance characteristics, critical to quality performance characteristics. Dr. Siva will be explaining about this in the coming stages. See, the critical to quality, we saw yesterday, we convert the VOC into CTQ. Okay, my friend says, I want good service. Then I want a good car. Then the key CTQ is the car must give a mileage of 15 kilometers per hour. So 15 kilometers per hour, that is the characteristics of the particular CTQ. So I have to finalize CTQ performance characteristics. Okay, then only I will be able to validate the measurement system. So in the first step, which you have to do in measure phases, you have to finalize the CTQ performance characteristics, followed by validating the measurement system. Okay, whether the measurement system I am following is correct one or incorrect one. If it is a correct one, whether the system which I am following, whether it is properly working or not, everything has to be validated properly. Normally, we used to say it as calibration in industries. Okay, calibrating. We regularly calibrate the instruments which we use in quality control department. We used to send it to NABL labs. Okay, so that is one kind of validation. Okay, then we have to measure the baseline performance. What is the existing performance of my process? Okay, we have to measure that. For that, we have certain measuring indices. We will see about that. Okay, so these are the three important steps. So after identifying the project, selecting the project, and developing a project charter, we have to finalize the critical to quality performance characteristics, and we have to validate the measurement system. Then finally, we have to measure the baseline performance. In the elaborate level, you'll be seeing some of the steps in a short manner. Okay, if you go for the green belt and black belt, you'll be learning all these things in a more elaborative manner. Okay, so how to finalize the CTQ performance characteristics? See, for example, CTQ measure. What is a CTQ measure? Okay, let us take the same example which we saw yesterday. My friend says a good car. He says 15 kilometers per liter. So CTQ measure is mileage. Okay, that is, if you convert it into better, if you convert into more technical terms, specific fuel consumption. Specific fuel consumption. That is fuel consumed per liter or per kilo, per mile or per meter. Specific fuel consumption. So that is the CTQ measure. Or if you want to have a simple example, let us take. I want to check the performance of my air conditioner. So how we will measure the temperature? For example, I am putting, say I'm just making my air conditioner run at 20 degrees centigrade. So here the performance will be the room temperature, the CTQ measure will be the room temperature that the air conditioner is able to create. So the CTQ measure is the room temperature. Okay, before going to that, we need to know what type of data it is. So actually we have two type of data, continuous data and discrete data. Continuous data is measurable, discontinuous data is countable. See, I want the session to be quite interactive. How many participants are there now? Anyone of you, how many participants are there now?
20.
Yes,
20.
Can you say 20.5?
No.
No. So 20, it is a countable data. That is this discrete data. Okay. So if I ask you what is the time now, you can give me, could you please give me an exact time?
2:18.
Okay. So you may say 2 o'clock, or you can say 2 hours, 18 minutes, 40 seconds. So this is measurable data. So when you are choosing a CTQ measure, you have to identify what kind of data it is. Then now you can you say now what kind of data is temperature?
Continuous data.
Continuous.
Absolutely, absolutely very good. Continuous data. Okay, so now the data type is continuous. Okay, unit of measure. What is the unit of measure of temperature? Anybody else?
Degree Celsius, Kelvin, Fahrenheit.
Absolutely wonderful. Excellent. So unit of measure, you must know the unit of measure. Without the unit of measure, the data will be entirely invalid. So for temperature, it is degree centigrade or degree Kelvin or Fahrenheit. And what is the operational definition? This is I have to explain. See, I have to define when my operator has to measure the data. There must be conditions. Okay, I want to check the room temperature of the room when the air conditioner should be in operation. The air conditioner should be in operation. If I check the room temperature while the air conditioner is in off condition, there is no use, right? I cannot measure the performance of the air conditioner. So first operational definition is you must measure the temperature when the air conditioner is switched on. Then all the rooms and windows must be in closed condition. Okay, then you have to say, you can add operational definitions like this. You can say at the time the room should maintain in 20 degrees centigrade for at least half an hour. So if only we provide this kind of operational definition, my operator will be able to take the data, will be able to collect the data and correct conditions. Otherwise, he will go to the room, he will just check the thermometer and write the temperature. He won't bother whether the air conditioner is on, whether the temperature is 20 degrees centigrade in the air conditioner. He won't bother about that anymore. So we have to provide the operational definition. Then the lower specific limit and the upper specific limit. What Dr. Sivakumar explained you in a clear manner with a lot of examples yesterday. So I have to define the lower specification limit and the upper specification limit. And I have to fix the target which I want. So I want good cooling, and the temperature and humidity at that of the cooling must be this value. So a target can also be fixed. So this is how we finalize the CTQ performance characteristics. Okay, is everybody clear with this? Clear?
Yes.
I can get a yes or no. If you have doubts, you can ask. Yes?
Yes, sir.
Okay, thank you. So this is how we finalize the CTQ performance characteristics. So you can write 3, 4, 5, 6, 10 CTQ performance characteristics, out of which you can finalize which is most important. Okay. Then we have to go for a measurement system validation. What is this measurement system validation? See, actually we have two procedures. See, for example, if you want to check welding, okay, you can have American standards, or you can have German standards, or you can follow Indian standards. For example, if my client is FL Smith, I will be following German standards. If my client is from Japan, I will be following Japanese standards. If my client is from America, from somewhere else, I will be following American standards. So likewise, we have validation procedures for measurement system also. That is, first one is MSA and another one is AAA, that is measurement system analysis and attribute agreement analysis. Both the systems will check whether the existing measurement system is adequate enough to collect the data properly. Okay, so as I told earlier, if I have to measure 60 centimeters, I need to use a 1 meter scale. I cannot use a 30 centimeter scale to measure a 60 centimeter accurately. So I need to check whether my existing system is properly calibrated, my existing system is properly adequate, my existing system can give data which are credible, which are authentic. So this MSA and AAA are validation procedures to check the credibility, adequacy of the measuring system available in the company at the time, in the organization at the time. Okay, normally the measurement system analysis, MSA, is used for continuous data. All of us know what is continuous data. And AAA, attribute agreement analysis, is for that is countable data, okay, or discrete data. So this is how we can validate the measurement system. Okay, another thing is baseline performance measurement. How we measure the baseline performance? Actually, for that we can calculate certain parameters like sigma level. Dr. Siva explained about sigma level detailed, how you will be doing some exercise also, how to calculate 3 sigma, 6 sigma and all using the GEMS exercise. So it is not a, it will be understood easily at the time. Then yield. What is the first pass yield, second pass yield? For example, if if I am giving raw materials for 100 components to my workshop, how many raw materials are converted into product in the first pass itself without any rejection, without any rework? For example, if out of 100, if 90 raw materials are converted into product without any rework, that is called the yield, first pass yield. So likewise, we have to calculate the parameters. Then capability indices, very interesting, CP and CPK. process capability indices. So we have certain ranges. It will be around 0.67 to 1.33. So anything above 1.33 is always good. So you'll be calculating this parameters, these capability indices, to check whether what is the condition of our existing performance. So to know the existing condition of your performance, you can calculate these parameters and identify the levels. Okay. So let us come to the tools. So what are the tools? We can use a lot of tools. Gauge R&R is there, what Dr. Siva is going to explain you. Okay, with the help of some simple activities. Then histogram, all of us know histogram. Okay, histograms can be used. Pareto chart, we saw Pareto chart yesterday. Okay, then control charts. So many control charts are available. To know about these control charts in detail, you have to go through this green belt and I believe black belt programs. Then MSA, run charts, check sheets, all these things will help you to execute the measure phase in a authentic, in a valid manner. So we saw the objectives, we saw the steps which we have to follow, and we saw the measuring the baseline performance. These are the important things which you have to do in the measure phase. And finally, when we come out of the measure phase, we will be having a proper operational definition. Why we emphasize on operational definition? Because without proper operational definition, the data which we collect won't be correct. If it doesn't inform my operator how to collect the data under what condition, he won't collect it properly. As I told, he will go to the room and just take the temperature. He won't check whether the room is closed. He won't check whether the AC is on. So operational definition is important. Then we will choose a measurement system analysis depending upon the type of data which we are going to work with. Then we go with the baseline performance measurement. Okay, now we are going to see some of the important MSA terms. Okay, so we will see that is measurement system analysis term. So in the yellow belt, we are going to see the some of the MSA related activities only, MSA related topics only. So the measurement MSA stands for measurement system analysis. Okay, in the MSA, we have three important terminologies: bias, linearity, and stability. We will see what are they. So what is bias? Let us see this as an example. See, it is a value. Bias is a numerical value. Okay, that is a difference between two values. That is average measured value and true value. What is average measured value? For example, here we have a standards. Okay, here we have a set of readings. Okay, that is a measurement is taken using a dial caliper. Okay, and the measurement is given below 25.425. You follow the cursor 25.425 and 25, 25, 25, 25.375, 25.4, and finally 25.35. Okay, so now the process tolerance is given as 0.25. Okay, so what is the average value? I add all these 10 readings and divided by number of times the reading occurs. That is, I have taken 10 readings, so number of times is 10. What is how to find the average? Add all the values. So it is 254.051 divided by 10. So the average value is 25.4051. Now to find the bias, I must subtract the true value from the average value. True value is the actual value which we got during the measurement. Okay, so 25.4051 minus 25.400. So this is the first one. Okay, that so the true value is 25.40. That is actual value. So the bias is, so sorry, sir, actually the true value is 25.4 here, which is given here. Okay, so the bias is average value minus the true value, which is given here. Okay, the standard value, which is given here. So the bias, that is a difference between the average measured value and the true value. The true value, which is required, is 25.4, which is given in the data. Okay, so the bias is, the difference is 0.0051. Okay, this is bias. So this is an important term which you must know in the MSA. So the bias is the difference between the average value which my operator has taken to the value which I actually want, which I need. Okay, so average minus true value. Then what is linearity? Previously, I have calculated bias. Okay, what is linearity? The consistency of a bias. Okay, over a range of measurement. See, for example, this is the bias, perfectly bias, zero bias. Okay, if my average value is 25.4, and the true value is also 25.4, then the bias will be 0. The difference will be 0. Okay, that the black line represents that difference. There is no difference between the average value and the true value. Both of them are 25.4. So the bias will be 0. Suppose in our case, we got a bias of 0.0051. So this this blue line, it indicates a bias. The blue line indicates the bias. See, in this case, if you go ahead and subtract the, in this case, if you go ahead and subtract the measured value of each and every data which you have measured, for example, let us take 25.4051 minus 0.425. You'll be getting a value. You have to plot all the values. And if the line, if it is parallel to the black line, then it is called perfect linearity. That is, if the bias value is constant for all the data which you have measured. Okay, that is, if the difference is constant for all the data which you have measured, then it is said to have a constant bias. That is called perfect linearity. That is, if the difference between the average value and all the measured value, if it is constant, if it is more or less very similar, then that is said to be a perfect linearity or constant bias condition. If it is not constant, if it is varying, then you'll be getting a blue line like this one, green color one. It is called poor linearity. So either your data has to be in the perfect linearity or in the zero bias, okay, or in the poor linearity. So it has to be either in the constant bias condition or zero bias condition or poor linearity condition. So first we saw what is the bias. Now we saw what is linearity. Okay. Then stability. What is the stability? That is bias over a longer period. See, for example, you can see the two graphs which are shown here. See, in the first one, you can see the common cause variation is in control. That is, it is within a particular limit. Okay, so there is some stability over the particular process. So the stability is the ability of a measurement system to produce same values over a time when measuring the same sample. For example, I sent two operators. Okay, both of them are having two thermometers. They measure the room temperature with the first thermometer. They came back. The first operator again goes to the same room and measures the temperature and check the temperature using another thermometer. So I am getting more or less a similar data. Okay, so the stability means if my equipments, if my measurement system, if it is capable of producing a similar values when the same data, when the same property, when the same characteristics is measured again and again. See, for example, you are using a thermometer to measure your body temperature. Now I am measuring at 2:30, it is showing 98.4. By 3 o'clock, if it shows 100.4, okay, but I doesn't feel any fever, like any feverish, I can say that the particular measuring a thermometer is wrong. It is not a stable one. It doesn't have the ability to produce the same value over time for the same parameter. So stability is the ability of an measurement system to produce the same data even after taking so many times within any time interval. For example, if I check the readings after 1 hour, I am getting the same reading or similar reading, very close one. Then you can say that particular measurement system is a stable one. If it is showing so many special causes, at the bottom you have a graph, you can see that it is having some abnormal special causes. A normal variation will be there. Normal, instead of 98.4, I can get 98.5, but I should not get 101. That time I should not get my body temperature as 101. If I get 101, it will be like the second graph, which is at the bottom. Then that is a special cause variation. Then I can say my system is not stable. It is showing different readings in same condition in different times. So these three terms are very, 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 very important for MSA. Okay, then we have other terms like repeatability. What is this repeatability? See, and reproducibility. See, for example, I am measuring the temperature. First time I am getting 98.4. Second time I am getting 98.45. Third time I'm getting 98.35. Say I am not able to produce the same readings. Okay, that is called repeatability error. Even though I am using the good measurement system, same equipments, calibrated equipments, I may not be able to get the exact readings because of this repeatability error. And then reproducibility. So myself and Dr. Sivakumar are going to check the temperature. I am getting 98.4, Dr. Sivakumar is getting 98.5. We are using the same measurement system. So there is a reproducibility error. Okay, so in measurement system, we have to look into this repeatability and reproducibility. In NDC, non-destructive categories. Okay, you will be learning about these things in the coming sessions. Then tolerance, AAA is what I explained, is used to measure the discontinuous data. Okay, so these are the three important terms: bias, linearity, and stability. These important terms you must remember in the MSc. So the main objective of this measure phase is to select the proper measurement system, which will be adequate for the process which I am following. And you have to choose either MSA or AAA, depending upon the data which you are collecting. And further, you have to measure the baseline performance. Okay, and the MSA which you are choosing will help these terms, this terminology like bias, stability, linearity, all these things will help you to understand the MSA in a much more better manner. Thank you. I think now Dr. Sivakumar will be continuing with the measure phase of the